Hello, welcome friends. In this session, I will be explaining you about what big data is and also what is the technology needed to process this big data. Okay, so nowadays you are coming across this buzzword big data, big data. Okay, everywhere you go, in every field you find this word buzzing around. That is big data. Okay, so what actually this big data is, I would like to explain you in a very simple terms. Big data in general, it's lots and lots of data. Okay, data in terms of terabytes and petabytes is considered to be as big data. Okay, and also from my perception, when you have a lots of data at your end and you are not able to process that data on your single machine, then that data also can be considered to be as big data or a huge data. Okay, so the thing is like from where this big data term was being coined. Okay, the term actually was being coined from the field of genomics or the sub part of astronomy, wherein people every day they come across a lots of data. Okay, they deal with a lot of data for analytic purpose. The data is nothing but the data generated through the satellites or the sensors, okay, of the satellites. Fine. So there actually they came with, or they actually coined this term as big data, because they in their day-to-day life they used to deal with data. Okay, and some point of time they find that the data is very huge, very large. Okay, so actually the data which is very huge and large, what do we call it as? So they called it as big data. Okay, now, also one more very important thing is like nowadays, like we are into a technology, or we are into a world wherein every day we create 2.5. Okay, over here it has been 2.5, but actually my perception is it's more than that. Okay, 2.5 or 5 quintillion bytes of data is getting generated every day. Okay, why is that? I'll tell you. Okay, now let us be specific with big data. Big data is a term for the collection of data sets, so large and complex that it's difficult to process on your RDBMS platform. Okay, we know that RDBMS is meant for storing structured information like employee information, student information, wherein you can fire some queries and get some results from those queries. Okay, so if we consider an employee information is composed or he is having the attributes like employee ID, employee name, okay, and designation, the project on which he works on, and the salary overall. Okay, so that is same to all the employees. Okay, if we think about an employee for a particular company, it would be same for all the employees. So that becomes a structured data which you can store it in a table in the form of rows and columns. Fine. So that data can be considered to be as structured data which RDBMs can store as well as process it. But big data, when I say, it is unstructured. Most of the data is unstructured. Okay, and also it is very complex, very huge. Fine. So why it is unstructured, very huge? Okay, I'll tell you next. Okay, so and one more thing. Okay, I said what is every day we create 5 quintillion bytes of data every day. Okay, and 90% of the data in the world today has been created in the last 2 to 3 years. Okay, if you consider the whole world's data right from the day when the people started collecting information in the form of pictures or paintings. Okay, so out of those data, okay, the if we consider entire data as 100%, the 90% of the data has been created in the last 2 to 3 years. Okay, just imagine what is the reason for this as well as this. Okay, daily we are creating 5 quintillion bytes of data. The main reason is the tools and technologies, the gadgets that you are using, and the effect of social networking sites like Facebook, Twitter, WhatsApp, okay, you and LinkedIn. Okay, there are so many organizations which are working with huge amount of data. Okay, why I said it is unstructured and also it is complex is because if you consider Facebook, now I may be having an account, other people also all over the world, crores of users are using Facebook. So every day to day life they are uploading image, somebody is uploading a audio, somebody is uploading a video, somebody is uploading a text, somebody is uploading a very different type of information. So such kind of data is considered to be as unstructured data. Okay, now storing employee information is fine, but storing audio as well as video as well as text as well as see audio video, again here you might think that all the videos can be stored at one place, but videos are also varying size, no? Some videos are of 10 minutes, some videos are of 1 hour, some videos are of 2 minutes. So again that is varying in nature. Okay, so such data is considered to be as unstructured. So this big data is unstructured complex data. Okay, so if that is unstructured and complex data cannot be processed on your RDMS platform. So what is needed for that, we'll see further. Okay, so I hope you have got the idea about what big data is now. Okay, so 90% of the data, okay, just imagine it has got generated in the last 2 to 3 years. Okay, because all it's because of your Facebook, your Twitter, LinkedIn, everybody are involved into generating the data. Okay, you upload the image, you upload a video, you upload audio, where that data goes to the servers. Okay, so those are at a very high challenge wherein how to manage that data. Okay, next, the key enablers for the growth of data. Okay, so the key enablers for the growth of data is nothing but, okay, your system itself. Okay, now if you are, they see now how it has happened is every human being's tendency keeps on changing. Okay, now if you just consider ourselves from here onwards till 5 years before, we were happy with small simple gadgets, but now we have a very hunger for new kind of gadgets, new kind of processing power. Now we are not happy with dual core processors in your mobile phone also. Okay, we are we want still more processing power. Okay, now if you have a processing power high, then that mobile phone or laptop which is having processing power high will obviously generate more data. If you consider one Pentium 1 machine on which you are trying to upload an image on Facebook, it will take a lot of time. But now if you have a i5 machine on which you are trying to upload an image, within no seconds the data is getting uploaded. Okay, let it be audio or a video. Okay, so that is actually having an impact in the growth of data. Getting, so increase of processing power will obviously increase the generation of data. Okay, now if there is an increase in processing power, obviously there should be increase in the storage capacity also. Okay, I'll just give an example. If you have a very best highway in the world, what is the use if you are driving a bullock cart on that? Okay, obviously you will be needing what, uh, good vehicles like Lamborghini car. Okay, on the same ways there should be some balance. If you have a huge processing power, then there should be storage capacity also. Okay, and one more thing is availability of data. Okay, the key enablers for the growth of data are like increasing the processing power, storage capacity, and also availability of data. The meaning of availability of data is anytime you request for a service. Okay, now for example, Facebook only, never it says no. The moment you enter your user ID and password, it will start providing you the service. Okay, what service Facebook provides is it is engaging you with the friends. Okay, Facebook is actually a engagement or it's an engaging tool which actually engages you with people whom you like the most. Okay, so over here Facebook has never said that I cannot process your user ID password and I cannot give an access to your account. It has always allowed you to access your account. Okay, so that is the meaning of availability of data. Means they always maintain some backup server. If one server is down, then there is another server which is always up and running. Okay, that is the meaning of availability of data anytime you request. Okay, So these are the key enablers for the growth of data. Okay, increase in the processing power. Now if you imagine again, I'll give one more example. The mobile phones, okay, which were 2 years or 4 years before, okay, on which if you had installed WhatsApp, then maybe you are busy with your WhatsApp, okay, and after maybe for some 5 hours you've put off your mobile phone, and the moment you on your mobile phone, if it would have been an old mobile phone, then really your mobile phone would have got hanged, okay. But now you have so high end gadgets or high end mobile phones like octa core processor, uh, mobile phones you all are having, on which like the moment you turn on your data, the let there be thousands of messages like on WhatsApp, the mobile will not go hanged, okay. So that is the actually, if mobile is not going hanged, then obviously data is getting generated, fine. So that is okay the reason. If there is an increase in the processing power, then obviously there is a uh, data getting generated at a high rate, okay. So I'm speaking about big data, big data. Why this big data is needed? Okay, the main purpose of this big data is analytics. I want to analyze. Okay, the big data is nothing but your past data. Okay, the past data I want to keep it for analyzing purpose. Okay, so you would be getting some hidden pattern over here. Now suppose I ask you, uh, what is the season in the month of June, July? You'll always say that it's rainy season. Okay, so from the past so many decades, okay, people have understood that there is a pattern in the season. Okay, that in the June, July, August, this is a month of rainy season, then winter season, then summer season. Okay, this is what is called a hidden pattern. How did they come to know this? By the past data. Okay, so identification of hidden pattern and unknown correlations. Okay, that is the reason we need this big data, data in term. Okay, now one more example is your stock data. Okay, now anybody would be very much interested in buying some shares in the stock. Okay, but everybody would don't want to take risk also in the meanwhile. Okay, for them there is some privilege or some systems, okay, which are now readily available for analyzing the shares or the market, okay, stock market, wherein like if you want to know what was the behavior of this product, okay, of which share you want to like purchase, the behavior of that product is always available in terms of these graphs. Okay, the graphs are being generated again based on the data analysis that they have done. Now for a particular product, you want to see in the year 2013 to 14 what was the behavior in the sense what, when the share went high, when the share went low. Okay, so that you can understand it, or you can do an analysis by firing some queries on that data. Okay, so that will actually help in making better decision. Okay, and also like suppose this, what do you mean by competitive advantage is, suppose I am a manufacturer of some mobile phone and I want to launch my mobile phone. Okay, so over here when I try to launch a mobile phone, I don't blindly launch a mobile phone. Okay, I want to do a study of market. Okay, now Micromax, where was it? Okay, if Micromax would have launched their product 20 years before, then they would have never come across, or they would have never become popular. Why they are popular? Because now there are so many analytic tools available. Okay, they did the study of Samsung mobile phone. How did they branded their product? The same they followed Micromax people. Okay, all this is because of data analysis. Okay, so if a Micromax person wants to launch a product, he'll always see the similar kind of product, how it behaved in the market, in which season it was the market was high, in which season it was low. Okay, so that actually helps in better decision making. Okay, let it be strategically or operational. Okay, this will actually help in effective marketing as well as customer satisfaction. When I say customer satisfaction, see, I being a person, normal user, I if I want to go and purchase a new mobile phone, I always go and check the customer reviews. Okay, so in the customer reviews, if I find that everybody has written for a particular product, product is nice, product is good, product is awesome, then I'll go and buy. If somebody writes a negative comment or negative review saying that everything is fine, if battery power is low, then I'll think twice. Okay, so that is what is like customer satisfaction, whether I am satisfied or not. Okay, so if everything is fine, everything goes hand in hand, then there is obviously increased revenue. Okay, so why that big data is needed? Because of why we need that big data is for analysis purpose. Okay, now I'll give one more example. You might have heard about the serial, okay, reality show Satyameva Jayate. Okay, that is considered to be as one of the highest TRP rated serial. Why? Because they did a study on the past serials, okay, or the past series of their viewing. Okay, so over there they just did what is they gathered or they grasped the Twitter data. Okay, people tweet no about any product or any movie or any serial. Okay, people start tweeting. Okay, they did what is they started taking the Twitter data. Okay, and they understood people sentiment, what people like, okay, what people around are interested in, what kind of stories they do like. Okay, so based on that they did a study. So based on that they came up with this Satyameva Jayate, when it is considered to be as one of the highest TRP rated reality show. Okay, the same is happening in entertainment industries also. Okay, the Hollywood movies, okay, they don't just launch the movies, they do a study, they do a very strategic Twitter study wherein they understand the likings of the people. Okay, nowadays all the movies are coming in 3D. Why? Because people like the 3D effect. Okay, so all this is again because of data analysis. The Twitter data is nothing but again past data. Okay, so they do what is they gather this Twitter data. Okay, the tweets whatever people have tweeted. Okay, those main positive whatever is there they grasp it, and negative things are there, they also understand that what in which areas they need to improve. Okay, in which areas they need to improve, and based on that they make a decision or they make a good movie for the next upcoming season. Okay, so that is where we need big data for analysis purpose. There are many applications of big data analysis, like smarter healthcare, multi-channel sales, finance, trading, manufacturing, traffic control, telecom, fraud and risk. Okay, churn, customer churn prevention, then search quality. Now you see Google also, like it has improved. Okay, if you consider Google, which was 10 years before, and now you see when you just type in one simple query, it will give so many options. Okay, so many options because they have improved their search quality. They have just gone back to their past data and they understood what people and how people like or how people query. Okay, so the data analysis actually helps in various fields. Okay, now big data in India. Okay, the main question is the status of big data in India. Okay, this is actually going to help the young generation who are just passing out or they are getting graduated. They need to decide on. Okay, now it's gaining attraction. Big data and its technology is gaining attraction. Okay, over here huge market opportunities for IT services. Okay, is 82.9% of revenue. Okay, and analytics firm 17.1. So here there is a huge demand. Okay, there is a great demand for, because why this is so, because there are less people who are doing work on analytics, so there is a wide range of jobs which are still available. There are lakhs and lakhs of jobs which are still available in data analytics. Okay, so there is a huge opportunity for the young graduates wherein they can enter into this field and make their career. Okay, so current market size is $200 million by 2015. Actually this should be like 2020. Okay, current market size, that is with respect to 2015, it is 200. It might be 400. Okay, wow, it is actually one billion dollar. Okay, by 2020 it would be $5 billion. Okay, by 2020 it is $5 billion. Just imagine. Okay, the opportunity for Indian service providers lies in offering services around big data implementation. This is very important. Okay, the opportunity for Indian service providers lies in offering services around big data itself. Okay, so now from now itself, like people or the students, like if they get into this analytics field, then they are going to land in very bright future. So potential talent pool with respect to big data. Okay, this is with respect to our Indian perception. So we have annual potential talent every year. This is the potential talent. IT professionals, this many. Graduates in maths, this many. Engineers, this many. Graduates in economics, this many. Postgraduates in math science, this many. MBS, this many. PhDs, this many. Graduates in stacks, this many. Graduates in statistics, only this many. This is actually the sad part. Okay. See over here, what says while the total talent availability is high, if you consider the total talent, it's the talent availability is high. Ready to hire talent for big data would be just 3 to 5%. It's a very sad part. Getting so no doubt this many IT professionals, graduates, engineers are there, but out of this, only 3 to 5% are good or eligible for hiring for big data. Why? Because of these things. Okay, people don't know what this analysis mean, and people are not getting into big data technology very soon. They are taking a lot of time for making a decision. And also the thing is the syllabus associated with big data analytics is nowhere in the universities. Okay, there's a lot of problem with the universities wherein they are not still upgraded with the new technologies, or there are so many tools and technologies which are available with respect to this big data. We have Hadoop generation 1, generation 2, we have Pig, Hive, HBase, Mahout, Crunch, Chalk. There are so many, like Spark we have, Scala we have, PySpark we have, Tej, Hama. These are all nowhere in the university. Okay, these are all the tools, okay, which are meant for big data analytics. Okay, so further, if we say or conclude, India will require a minimum of 1 lakh data scientists, okay, in the next couple of years, in addition to the data analyst. Okay, data scientists, data analysts, and data managers. See, everything is associated with data. Okay, so there might come a day wherein there is a separate branch for data, like data science. How we have computer science, the same way data science. Okay, so India will require a minimum of 1 lakh data scientists. So see, I'm telling what is like, you have so much of talent pool, and only out of that 3.3 to 5% of them are eligible for data science. So what are we supposed to do now? If this is the case, then I simply suggest is get into big data training, get into the technology, get explore the technology. If you see, technology will not come towards you, you should go towards the technology. Fine. Next, future of big data. Some things like you can just keep on listening. These are like histories, like you can just see these things through various articles. Okay, the industry on its own is worth more than $100 billion and growing at most 10% a year, which is roughly twice as fast as software business. Okay, big data is twice as the software business as a whole. Okay, then sources of big data. Okay, as I was telling, what is the actual source? Why this data is getting generated higher and higher? That is again because of social networking sites like Facebook, LinkedIn, Twitter. There are many others like Google Plus. Okay, YouTube, again people are uploading their videos on YouTube. Okay, and also stock market I was telling about, like Nifty, Sensex, Nasdaq. Okay, they all are involved in data analytics, and again data is getting generated after every second. Data is getting generated over there also. Weather forecast. Okay, the sensors which are being placed in the cities, Okay, they keep on sensing the data, they keep on generating the data. Okay, so weather data again, if you consider one day's weather data is to 250, no, not 250, 5 GB of data. Only one day's sensor generated data is 5 GB. Just imagine if I consider to predict the future data, future weathercast, I need last 10 years of data. Okay, so last 10 years of only one day's data is 5 GB, then last 10 years data, just imagine how much data I need. Getting? So that is again a huge Herculean task. Okay, then servers like your Yahoo, Rediff, Gmail, they also see you keep on getting mails. Okay, you send mails. There again, you attach some documents, you attach an image. Again, that is nothing but you are giving a space for data to be getting generated. Then medical data, there are so many equipments associated with the patient. Okay, so those equipments keep on generating data. Okay, the New York Stock Exchange generates 1 terabytes of new trade data. 1 terabyte, they say. Okay, every day. But it's not just 1 terabyte, it might be 5 to 10 terabytes. Now if you consider the business and the market, it is generating 5 to 10 terabytes of data. Facebook itself generates 250. This is not 250, huh? It is 500 plus terabytes of data every day. Facebook itself generates 500 plus terabytes of data every day. Okay, the same holds with Twitter and LinkedIn also. Now, if you understand this characteristic of this unstructured data, this unstructured data is nothing but the data generated through Facebook, Twitter, WhatsApp, and all. Okay, so this part is unstructured, it's going on growing. Okay, if you consider from year to year, 1970, 1980, 1990, 2000, 2010, 2015, this part is your relational, employee, student related information, like which are structured data. Okay, so this is unstructured data. It's going on and on. Okay, so data is growing exponentially. Okay, at a very high rate. Okay, now whenever you are being asked what this big data is and what is the IBM's characterization of big data, you need to understand that there are three V's. Okay, apart from three V's recently added are two more V's. Okay, so initially we had volume, velocity, and variety. Two more V's were added like value and veracity. Okay, so IBM say what is a data is considered to be as big data if it is having huge volume. Okay, in simple terms, a data can be considered as big data which is having huge volume. Fine. Then a data can be considered as big data which is having a very high velocity. Okay, see, I'm saying what is like in the previous slide you saw, Facebook is generating data at 500 terabytes per day. Then it's having a very high velocity. Okay, so velocity is the rate at which the data is getting generated. Fine. Then data is the big data can be considered to be as big data if it is having variety. Again, consider Facebook, there are variety of information like documents, images, text, normal text, audio, video. Okay, so that is actually a variety of data. Okay, variety of information together forming a data. Okay, and the value. Okay, now I was saying about weather forecast. Okay, now weather forecasting is nothing but predicting the upcoming days weather. Okay, so how do I do that? Based on the past data. Okay, based on the past 10 years data, I do what is some analysis. That analysis is done on a machine. Okay, on a machine or on a cluster. Okay, I'll tell you about that. So that analysis is done on machine, and for which we need 10 years data. If the data is false, the past data is false, then obviously we'll predict the future false. Getting the point? That is the reason the data, the big data is valuable also. Okay, you cannot analyze on a false data. Getting my point? That is the point why now the value has come into picture. The big data is valuable. Fine. Then next is veracity. Okay, some of the fields in some of the tuples you find like attributes like address 1, address 2. Like if you consider a normal employee information, you can find address 1 and address 2 in some of the forms. Okay, so there many employees might be having address 1, but some of the employees will not be having, most of the employees will not be having address 2. Okay, so the data which is doubtful, the data which is doubtful or not, you are not sure about, okay, that kind of data can be considered to be as veracity. Okay, having a veracity characteristic. Okay, I hope you have understood this IBM characterization of big data. Okay, let us move further. Okay, so common big data customers. Okay, now we have web and e-tailing. Okay, recommendation engines. Okay, you might have come across in web if you are doing some e-shopping. Okay, there you are searching for a product. Okay, say mobile, maybe you are searching for a mobile phone, and the moment you are trying to search mobile phones, then later on below you come across some other messages like people who have seen this also have seen this. Getting my point? That is what is called as recommendation. Okay, so they are actually targeting you through various ads. Okay, they are saying what is that is actually happened through how by understanding your behavior over here. Okay, now I'll just tell you one example. Suppose you are a user A. Okay, then there is a product, say product 1, product 2, product 3, product 4, and product 5. Okay, now you have user A, then you have user B, then you have user C, then user D. Okay, now suppose you are a user A, you have seen the product 1, product 2, and product 3. Okay, B sees product 3, product 4, and product 5. Okay, then C sees again product 1, product 2, product 3, product 4. Okay, D sees again product 1, product 2, product 3, then product 5. Okay, so by this what the algorithm on web does, what is like, they it see A has seen product 1, product 2, product 3. B has not seen all the 3 products, but he has seen 4 and 5. C has seen product 1, product 2, product 3, also product 4 and product 5. D has seen product 1, product 2, product 3. So the web, okay, on the web there are some algorithms especially running for particular products. Okay, they do what is, they understand that A, C, user A, C and D, they have similar likings. Okay, they have similar liking because you all have seen the same products. Okay, so now A has seen only 3 products. Okay, D has seen the next products. One second. Sorry friends. Now based on the likings over here, you are been grouped as part of these 3. Okay, A, C and D, they fall under one group. Okay, so over here what happens is C has seen the next product, D has seen next product. So we have seen only 3 products. So based on C and D's liking, you are also said that people who have seen these 3 products, they also have seen these 3 products. Means thinking that you fall under that category, okay, they actually recommend you that you can go ahead with further products also. Okay, that is what is meant by recommendation engine. The same way they target the ads also. Okay, now abuse search quality again has been improved. Okay, now if you have logged in into YouTube and through your Gmail account, and today you are searching for uh, some cricket related information, then tomorrow you will be searching for football related information, day after tomorrow rugby, then later on some hockey. Okay, so on the 5th day The moment you enter, say, film related information, any entertainment related information, you'll get entertainment related results also. Below that, you'll also get sports related. How did they come? Because they have understood your likings. So that is how search quality is improved. Okay, so you can try this. You can just log in, like on your YouTube. Okay, you should be logged in user. Then through your Gmail account, because all are synchronized, you know that. You just do a search for sports first, that is cricket, then football, then hockey, then later on you do a search for entertainment. There will with entertainment you'll also get the result of sports. Excuse me, friends. So next is abuse and check fraud detection. So sometimes you come across certain mails, okay, which you don't want to see or you don't want to view. Okay, you do what is you spam them. Okay, you spam them. So over here, next time you do the same process for some other mail also. Okay, you may come across certain mails like you have won 15,000 euro dollars. Okay, so you would be not liking such mails, so you go on spamming them. So next time what happens is, like when similar kind of mail that starts arriving at you, they are by default directed to the spam. So they have understood what kind of mails you like and what kind of mails you don't like. So that is how this fraud is detected, and they are put into spam mails. Okay. Next is like telecommunications. Okay. So customer churn prevention. Okay. So how can churn prevention, in the sense what, customer leaving your service and getting into some other service. Okay, so maybe you are fed up of the service provided by Airtel, you want to switch back to Vodafone. Okay, that is what is called as customer churning. They are leaving your service. Okay, how do you prevent that? How do the telecommunication industries prevent this? They can do what is, they can provide certain offers. Now suppose there is an employee working in Infosys. Okay, so he is working from morning 9 to evening 9. Okay, and he is busy with calling from 9 to say 12 o'clock. Okay, from 9 to say 11 o'clock. So his pattern is daily, like daily at the night times. Okay, he actually does most of the calls. So the telecommunication service providers, they can do what is, they can provide him offer. Okay, saying that your call rates are been like reduced during the night time, so that you can make the customer happy or customer satisfied. Okay, so that is how you can prevent this churning. Fine. The same lines, call data record and analysis. Calling data record and analysis, you can understand the behavior of the person usage for his calling. Okay, if the person is busy in the calls, then you can provide him some free offers. Okay, for say for 250 every month, you'll be getting unlimited call. Okay, by which customer also is happy, and you are also getting revenue. Fine. So that is how you can do the same. You can apply for networks also, network performance and optimization, wherein you want to provide a best routing path through optimization. Okay, you can do what is, you can do some experimentation. Okay, and based on the results that you get, okay, you can do what is, provide a better service and also predict failures. Fine. Move next. In the government sector also, like your Aadhaar card. Your Aadhaar card is totally based on big data technology. Fine. There are some other cases like health information exchange, gene sequencing, serialization, everything. Okay, nowadays, like everywhere, you have this data analysis going on, and many are satisfied with the service or the results that they are getting through analysis. Right. Now, till now, I said, okay, let us take a break, friends. Okay. Welcome back, friends. In the previous session, I had dealt with what big data is and also explained you and gave you an idea about what big data is. Okay, so from here on, we would be dealing with the tool, okay, that is needed for processing this big data, right? As I in the previous session explained you about the characteristics of this big data. Okay, so as I also mentioned that the big data is so complex and unstructured and large that it cannot be processed on a rdbms platform. Okay, so what next? I want to somehow want to process this big data. Fine. So if RDBMS is not there, then what is the tool that I would be using for processing that big data? Okay. So here is the answer. The answer is Hadoop. Okay, Hadoop is the tool that will allow you to process your large or big data. Okay, so what Hadoop is in general terms, it is a software package. Okay, in technically we call it as a framework. Okay, Hadoop is a framework that allows you for distributed storage of the large big data and also helps you in processing that big data. Okay, so it's an open source software. Fine, you can easily freely download it and install it or configure it on your machine. Okay, so it's what Hadoop is. Hadoop is a framework that allows for distributed processing of large data sets across clusters using a simple programming model. Okay, so this framework, this Hadoop, okay, allows you to install, okay, the so package on a cluster of machines, okay, using a simple programming model. What that programming model is and all, we'll deal it in the subsequent slides. Fine. Who actually is the person responsible for Hadoop? Okay, the person is Doug Cutting. Okay, he was working with Yahoo. Okay, he in the year 2004 through Google white papers, read the paper called MapReduce, okay, and he was working with Yahoo, okay. So he combined the feature of MapReduce and distributed file system, okay, which was already available in Yahoo. Okay, here when I say Hadoop and its distributed storage and distributed processing, okay, it was already available. Okay, that technology was already available and was being practiced. Okay, but the thing is, this Doug Cutting, a scientist, he did what is he combined the feature of storing and processing. Initially, what was happening is storing was done by some software, processing was done by some other software. That is at the distributed level. Okay, Yahoo performed already had DFS. Okay, DFS in the sense distributed file system. They in Yahoo, the company already had a very big cluster of machines. Okay, on which there was a file system called DFS, distributed file system. Okay, on which the data was stored at the distributed level. Right. So Doug Cutting combined the feature of MapReduce. MapReduce is meant for processing over here. MapReduce is meant for processing that distributed data in a parallel manner. Okay, so Doug Cutting was working with Yahoo and Doug Cutting with another scientist called Caffarella. Okay, Michael J. Caffarella. They were working on a project called Nutch. Okay, Nutch is nothing but a search engine. Okay, so they combined the feature of MapReduce and the distributed file system and called it as NDFS. NDFS. NDFS refers to Nutch distributed file system. Okay, then soon they extended this project to what is called as Hadoop. Okay, from there the journey begins. Okay, but you might be wondering why this name Hadoop. Okay, from where this term Hadoop came and what is the relation of this elephant, okay, toy elephant with this term Hadoop. Okay, this is a very simple story. The time when Doug Cutting and his teammates were thinking about what to give the name for this new technology, okay, which combined MapReduce and the distributed file system, okay, they were thinking to give a name for this technology. Okay, so that point of time, Doug Cutting's child was playing with a toy. Okay, the toy was nothing but an elephant. Okay, small toy elephant. So like the children, okay, they have the tendency to call some things with some names, some funny names. Okay, so before we telling the child or we telling the children that this is a dog, this is an elephant, okay, they call it by some funny names. Okay, the same thing had happened with Doug Cutting's child also. Doug Cutting child, which like he was playing with the toy elephant, child used to call this elephant as Hadoop, Hadoop. Okay, so that is the reason the name actually Hadoop. Okay, there is nothing related to elephant being big and data being big. Okay, so there is no relation with the term big elephant and the big data. Okay, it's just a coincidence. Fine. So I was telling about Michael J. Caffarella. Okay, they developed Hadoop to support distribution for the Nudge search engine project. Okay, then later on, the project was funded by Yahoo. Okay, so Yahoo gave the project to Apache Software Foundation later on. Fine. Then Hadoop was been also open sourced. Fine. There's some more additional things. Okay, like history. Fine. You can understand these things. Then in the year 2008, Hadoop wins terabyte sort benchmark. Okay, so Hadoop did what is it sorted 1 terabyte of data in 209 seconds as compared to the previous record of 297 seconds. So by that time, Hadoop was being like considered to be as very popular distributed processing software. Okay, then later on in the year 2009, Aviro and Chwok became new members of Hadoop framework family, which gave additional features for Hadoop. Then in 2010, Hadoop's HBase, Hive, Pig, they become sub projects, okay, which were been completed. Then they added more computational power to Hadoop framework. Okay, in the year 2011, Zookeeper got added. In the year 2013, Hadoop 1.1.2 and Hadoop 2.0.3 alpha were been created. Okay, Hadoop 1.x.x is called generation 1 and Hadoop 2.x.x they are called generation 2. Okay, so and with respect to Hadoop 2.x.x, Ambari, Cassandra, Mahout were been added. Okay, Ambari is a user interface, okay, that allows you for working on with HBase, Hive and Pig without getting into the intrinsic details. Okay, it allows you for an abstraction wherein you can work with the tools like Hive and Pig. Okay, Cassandra is like a data warehouse platform wherein it allows you for storing data and also allows you for data getting replicated. Okay, so Mahout is a machine learning tool. Okay, so let's move further. So one more very important thing is like as I was speaking about cluster. Okay, so cluster in the sense the interconnection of computer systems to form a very huge file system. Okay, so Yahoo now is in the world having the biggest cluster. Okay, so it is having a cluster of 4,000 plus machines. Okay, after Yahoo we have the Facebook having the next largest cluster. After Facebook we have LinkedIn. Okay, and when you just open the Yahoo page, okay, the stuff whatever you see over here on the Yahoo page, okay, all are the data which are being processed by Hadoop framework. Okay, when you visit Yahoo, you are interacting with the data processed with Hadoop. So whatever is available over here, it is the data processed by Hadoop. Okay, see, content optimization, search index, ad optimization, content feed processing, it's all are result of Hadoop. I was mentioning about machine learning, that is spamming. Okay, so the mails that you don't like or which you frequently keep on spamming, similar sort of mails they get by default into the spam folder. Okay, so that is nothing but machine learning. Next, so Hadoop is now Apache's top level project, and it is an open source implementation of frameworks for reliable, scalable, distributed computing and data storage. Okay, it's a flexible and highly available architecture for large scale computation and data processing on a network of commodity hardware. Okay, I just want to make one point very clear over here. Okay, about this term commodity hardware. Okay, so commodity hardware, so over here the Hadoop, okay, Hadoop package, okay, is being installed on cluster of machines. Okay, you have cluster of machines which are again over here interconnected to each other. Okay, so cluster of machines which are connected to each other, and these machines are commodity hardware. Okay, commodity hardware in the sense what, they are cheap hardware. Cheap hardware means they might be lacking in processing power, they might be lacking in some storage space. On some, there are some factors which consider this machine to be as commodity machines or commodity hardware. Okay, so Apache's Hadoop is installed on a cluster of machines. Okay, and those machines are commodity hardware. So when I say commodity hardware, they are prone to get failed. Okay, there might be disaster happening and this node may get failed. Okay, then if that is the case, then how am I going to justify that it is reliable? Okay, I am saying what it is, Hadoop is Apache's top level project which is reliable, scalable, distributed computing. Okay, it is also highly available. When I say commodity machines and machines are prone to disaster and they may go down, and I also suggest that they are reliable, highly available. How is that possible? Okay, so we'll come to know about those things in the subsequent slides. But remember that I am mentioning that it is reliable, highly available. Fine. Okay. So goals with respect to Hadoop is abstract and facilitate the storage and processing of large, rapidly growing data sets, structured as well as unstructured, and also provide simple programming models like Pig, Hive. Okay, highly scalability and availability. Again, over here the term availability. Use commodity hardware with little redundancy. Fault tolerant. See again, one more new term: fault tolerant, reliable, highly available, fault tolerant with commodity hardware. How is that possible? Okay, there are slight attractive features available as part of Hadoop. I would want to reveal those things. Okay, and also very okay. First, I'll do what is, I'll just tell you about why. Uh, Even though after using your commodity hardware, okay, you are saying that it is highly available, fault tolerant, reliable. Okay, now over here on the cluster of machines, on the cluster of machine, we actually install Hadoop, and Hadoop becomes a logical file system on top of these machines. Okay, so this is actually one drive, all together, all the machines together become one drive. Okay, one storage space. Okay, now over here, excuse me friends, now over here, when I say commodity, these machines are prone to disaster. Okay, that is one thing. Okay, now why I'm saying it is, the data is highly available. Now consider one data of size, say some MB. Okay, this data is been broken into blocks. Okay, into blocks. So this block is this. Okay, another block. Okay, so here replica of the blocks are been created. Okay, if I consider this block, its three replicas are been created. See over here, these are the replicas. Okay, and this block I'll create some more three replicas, like 1, 2, and 3. Fine. So these replicas are stored over here on these machines. This is one replica. This is another replica. This is third replica. Okay. Then what about this block? Again, it will be stored somewhere over here on one machine or one block over here, one block over here, another block over here. Okay, so by creating a replica, what actually is happening is that if one machine goes down, okay, then see over here I lost two blocks. Okay, but don't worry, the block is still available on other neighboring machines, like node this node, as well as the second block here on this node and this node. That is the attracting feature of actually Hadoop. Okay, so the attracting feature is what you are actually duplicating, okay, or replicating the blocks over here of the data. Okay, you are first dividing that data into some equal size blocks, and you are creating replica of those blocks. Okay, that is, and those replicas are being distributed across the cluster. Okay, so when I say distributed, if any one machine goes down, then its replica is readily available on other nodes. Okay, so that is actually the attracting feature. Now I say that it is highly available, reliable, okay, and fault tolerant. Fine. So I hope the characteristics, okay, that is highly available, reliable and fault tolerant are clear for people. Okay, and one more thing is, why go for commodity cheap hardware? That is also one question. Okay, now suppose you want to buy a brand new server, high-end server, okay, or a blade server, you may think of investing in terms of crores. Getting? You may invest in terms of crores, okay, or lakhs. Fine. Now, the processing what this high-end server is going to provide me, if the same processing is being provided or is being provided by cluster of machines which are again cheap, which on which you need not spend money in terms of crores, then why not go with these cheap machines only? Okay, so that is the reason the Hadoop, okay, is attractive. Okay, it allows you to store it allows you to install the Hadoop package in a distributed manner on a cluster of machines rather than on a single machine. Okay, so purchasing a high-end server which is costing you crores, okay, better than that is go for cluster of machines which will provide you the equal processing power as well as equal storage capacity. Equal processing power in the sense what? In the distributed manner. Okay, so over here when you are storing, it would be in a distributed manner. Okay, all the data, okay, whatever data you get over here, that data would be broken into parts. Okay, those parts are being distributed. Those parts are first their replica is created and they are distributed amongst these machines. Okay, and whenever you want to process the data, that time again parallel processing happens. You can parallelly access these nodes and the processing of data happens. Okay, that parallel processing, you know the advantage that it will take less time. Okay, so the goals and characteristics, okay, actually are very attractive with respect to Hadoop. Fine. I hope you have understood the concept over here. Next, we'll move further. Why distributed processing? As in the previous slide itself, I have told, okay, distributed processing helps you in saving time. Okay, let us take an example. Suppose there is a situation of reading 1 terabyte of data, okay, on one such machine. Okay, this machine has got characteristic like 4 IO channels. Okay, this machine has got 4 IO channels, and each channel has the capacity to process 100 megabits per second, mbps. Okay, remember there is a difference between megabytes per second, megabits per second. Whenever you are thinking about uh, processing processing the data, it is megabits per second, but whenever you are thinking about storage, it is megabytes per second. Okay, so there's a difference. Fine. Now suppose there is a situation of reading 1 terabyte of data on a machine which is having 4 IO channels, and each channel having 100 mbps. Okay, so what is the time taken? So it will take 45 minutes. All over, it will take 45 minutes to process this 1 terabyte of data. How this 45 minutes? See over here. I would like to elaborate the thing. Why 45 minutes? Now, you know that 1000 MB is equal to 1 GB. Okay, and 1000 GB equal to 1 TB. Fine. So this 1 TB, I'll represent it in this format. Okay, that is 1000 MB, 1024 MB into 1024 MB is equal to 1 TB. Okay, so that, okay, and I said that each machine has got 4 IO channels, so the data would be divided amongst the 4 channels. Okay, so this 1 TB, that is 1024 into 1024 divided by 4, and each channel has 100 mbps speed, data transfer speed rate. So I'll multiply it by 100, 4 into 100. So I'll be getting the time in terms of seconds, that is 2621.44 seconds. Okay, so if you want this time to be in terms of minutes, just divide it by 60. I'll be getting approximately 45 minutes. Okay, so I hope you have understood this. Now let us move further. Now, as I said, for 1 terabyte of data to be read on one machine, it takes 45 minutes. Suppose the same configured machines, if you have 10 machines, then the same 1 terabyte of data will take 4.5 minutes. Just 45 divided by 10, it will be 4.5 minutes. Okay, so I hope now the things are much more clear for you why we are going for distributed processing. Okay, now you understand what is Hadoop is a framework that allows you for distributed storage as well as distributed processing. Okay, so Hadoop key characteristics are economical, scalable, flexible, accessible, robust and reliable. Okay, so economical, why? Because we are dealing with commodity cheap hardware. Okay, and also you need not waste or you need not spend time on proprietary license over here. Okay, Hadoop is a open source. Okay, it's not a proprietary software, rather than it's a open source. That is the reason it is economical. Hadoop is open source, as well as it relies on it makes use of commodity cheap hardware. That is the reason it is economical. Scalable in the sense, in the cluster you can at any point of time add a system with slight configuration and take off a system, or take away one system from the cluster with slight configuration, not much. Okay, there's no much configuration needed. Anytime you can hook up a machine and you can take off a machine. Okay, that is the reason it is easily scalable. Okay, horizontally it is scalable. Fine, you can scale up to thousands of machines together. As I was giving an example about Yahoo has got 4000 machines together forming one cluster. Flexible. Okay, why Hadoop is flexible? The main reason is it helps you to store different variety of data. Okay, complex data like audio, image, video, text, document, paint related information, any kind of pictures, anything. Okay, you want to store, Hadoop allows you to do that. Okay, that is the reason it is flexible. Fine. Accessible. Hadoop is always accessible. Okay, Facebook makes use of Hadoop, Yahoo makes use of Hadoop, LinkedIn makes use of Hadoop. Okay, so that is the reason they are accessible. While they are accessible every time, highly accessible, Okay, Facebook, why they are accessible? See now, maybe I have an account which is like I have created an account from past 4 years. Okay, so an account is 4 years older, right? So if I want to view my information which I had uploaded, or my data which I had uploaded 4 years ago, it is still available in Facebook. Okay, why that is? Because they are providing the storage at the cluster level, very at the very high cluster level. And also one more thing is, if my data is lost also, even though if my block of my data is lost also, they have provided replication factor. Okay, that you have seen in the previous slides. Okay, if one node is down, then another node, through another node, the data is still available. Okay, so because of all these characteristics, it is robust and reliable also. Right? So these are the five very important characteristics of Hadoop. So Hadoop overall has got one architecture, overall architecture. This is HDFS. Okay. One thing you understand, Hadoop is meant for distributed storage as well as distributed processing. For distributed storage, we have a file system called Hadoop distributed file system. For storage purpose, we have Hadoop distributed file system. And for processing that distributed data, we have MapReduce. This is the new term, MapReduce. Okay. So whenever you store data on the Hadoop cluster, you are storing it on HDFS. And whenever you are processing that data, you are using MapReduce framework. Fine. So you have HDFS beneath, then on top of that you have MapReduce and HBase. HBase is nothing but again one more data warehouse wherein you are allowed to create tables, fire some queries on the tables, so on. Fine. Then on top of this MapReduce, you have Hive data warehouse system. The Hive is like similar like SQL. SQL like language, it supports. Hive supports uh, a language called HQL. HQL, it is which is similar to your SQL that is available as part of Oracle. So wherein you can fire some queries and get the results for analysis purpose. Then you have Pig Latin data analysis tool, Mahout machine learning tool, okay, which sit on top of excuse me friends. This high Pig Latin, Mahout, they sit on top of Hadoop and process data. Okay, there are some more tools like Flume, Scoop. If you are interested in putting structured data from MySQL to Hadoop, you can make use of Scoop. Or from Hadoop to MySQL, you can make use of Scoop. That is the reason there are two arrowheads. And also you might be interested in semi-structured data like XML or Twitter data. That Twitter data, if you want to process it on Hadoop, you can make use of a tool called Flume. Fine. Sorry, friends. Then you have Apache Uzi, which is the controller or the coordinator which takes care of workflow of the jobs. Okay. So for the first instance, you people will find these things difficult, the terms, whatever I've used. But remember one thing, Hadoop is composed of two core components. Okay, that is HDFS and MapReduce. So those two core components, we'll have a detailed study now. HDFS meant for storage purpose, MapReduce meant for storage processing purpose. Okay, in generation 1, MapReduce is called MR. In generation 2, it is called YARN, yet another resource negotiator. Okay, and in generation 2, it's also called MRV2. MRV2 refers MapReduce version 2. Okay, so core components of Hadoop are HDFS and MapReduce. HDFS meant for storage, MapReduce meant for processing. Now this is very important thing. So the five important daemons of Hadoop. Okay, over here when I say Hadoop is functioning, Hadoop is nothing but software package, as you all know. If it's a software package or if it's a software, then obviously it is composed of programs. Okay, so out of those programs, five important programs are your name node, secondary name node, data node, job tracker, and task tracker. So when I say Hadoop is functioning or Hadoop is running, then understand that name node, secondary name node, data node, job tracker, task tracker daemons are running. Okay, these are the five daemons or five processes or five programs which are responsible for Hadoop's functionality. Okay, remember this. Now, as I said, Hadoop is composed of two core components, that is HDFS and MapReduce, and it is composed. It works on the five daemons. It is based on the five daemons, that is name node, secondary name node, data node, job tracker, task tracker. They are also divided amongst those two core components. Okay, so you have HDFS and MapReduce. Fine. So name node, secondary name node, data node are among the HDFS. Job tracker and task tracker, they fall under MapReduce. Okay. So by this, what you understand is name node, secondary name node, data node, they are responsible for storage. They are responsible for storage. Then this job tracker and task tracker, they are meant for processing. Okay, so if they are divided amongst this HDFS and MapReduce, then obviously they will be doing the same task what this HDFS and MapReduce do. Okay, now there is also one more very important thing is about the relationship. Okay, there is a master slave relationship, master slave relationship amongst the daemons. Okay, so over here name node is master for data node. Okay, it means name node gives some job or orders the data node. Okay, on the same lines, job tracker orders or commands the task tracker. Okay, so under HDFS, whenever there is a task of storing some data, name node gives the task to the data node to store. To store. Okay, then whenever it is when it is term of processing, job tracker gives the task to the task tracker to process. Okay, so I hope you have understood over here daemon roles. Okay, over here you are understanding what is like the roles and responsibilities of each daemons. We know that there are five daemons: name node, secondary name node, data node, job tracker, and task tracker. And amongst those, they are again categorized into HDFS and MapReduce. Okay, HDFS in the sense those daemons are responsible for storage. MapReduce in the sense they are responsible for processing. Okay, among the daemons only there is a master slave relationship. That is, the name node is acting as the master for data node. The job tracker is acting as the master for task tracker. Okay, so name node commands the data node for storing purpose. Job tracker gives the command to the task tracker for processing purpose. Okay, I hope this thing is clear for you people. Now over here, you need to understand what is the, suppose there is a cluster. Okay, there is a, assume that there is a cluster of say 100 machines. Okay, now in this cluster, you understand one very important or basic thing is that there is one machine which is acting as master. There are no other masters over here. There is only one machine in the Hadoop cluster which is acting as a master. The remaining nodes are all slaves. Okay, so there is a master slave relationship amongst the machines also. Okay, so now I just want to make one thing clear is we are having these nodes. Okay, we are having the nodes, and these nodes, we are having these nodes, with these nodes, okay, are like based on the software installed on these nodes, they start acting. Okay, now suppose there is some machine, okay, on that machine if I install Windows 2003, then that machine starts acting as a server. If I'm installing DHCP, then it starts acting as a DHCP server. Okay, on the same lines over here in the cluster, the daemons are making the node either a master or slave. Okay, now over here, if there is a node, and on that node if name node and job tracker are running, then that complete node becomes the master. Okay, because you know that name node is the master and job tracker is the master. Okay, if both the masters are running on one machine, then that machine becomes master. The same thing has happened over here. On this machine we have the name node and the job tracker. Rest all machines we have the data node and the task tracker. Getting? So in the Hadoop cluster, one machine is acting as a master and the remaining machines are acting as slaves. Okay, so over here what is actually happening is, so whenever there's a request coming to this like cluster for storage purpose or for processing purpose, master actually controls and coordinates those requests. Okay, so after receiving the request, the name node gives the job to the data node, and the job tracker gives the job for the task tracker. Name node in the case of storing purpose, and job tracker in case of processing purpose. So it is not the only signal to only one data node. There is a signal for other data nodes also over here. See all the machines. Getting? So there is a controlled signal sent from the name node to the data nodes and job tracker to the task trackers, like this. Okay, so I hope this concept is clear for you people. Next, so as I said, this is a much more detailed view of the cluster wherein we have the master and the slaves. What makes a machine master? The name node and the job tracker. What makes the machine slave? The data node and the task tracker over here. Fine. Now you have understood the role of name node. Name node, the role is what? It gives the task to the data node. Job tracker, it gives the task to the task tracker. Data node performs the storage operation, task tracker performs the processing operation. What about secondary name node? Okay, there is one daemon left whose responsibility is not yet defined, or it is not clear for people. Okay, so for the first instance, if anybody views this diagram with name node, job tracker, data node, task tracker on all these slaves, okay, then secondary name node at this place, everybody would think that secondary name node is a backup node or the backup server. But your assumption or your perception is wrong. Okay, secondary name node actually is not the backup server, but it helps in the times when name node or this master node is down. Okay, understand this concept clearly. Okay, so secondary name node is not the backup server, but it actually helps in the times wherein the master node is down. Okay, how it helps? So secondary name node actually periodically, in the periodic sense, keeps track of the logs maintained by the name node. Whatever the status of the name node was, it periodically, like every after every 1 hour, okay, after every 1 hour, this secondary name node takes the snapshot of what is the status of this master node. Okay, so whenever the master node is down, then if you want to get a new master node, then you refer the secondary name node to what was the status of the master node. Okay, but there is again a flaw over here, some drawback. Like suppose secondary name node has taken the snapshot at 10 o'clock, 10 a.m. Okay, then if name node or the master is down at say 10:30, okay, then if you want to get a new master up and running, then you would be referring to the status what was at 10 o'clock available in the secondary name node. Okay, so whatever task that master had done in this half an hour, okay, is lost. Getting my point? So this is what is a drawback in the with respect to the secondary name node. Okay, and this entire thing or whatever drawbacks is available in the generation one. Okay, note down that you are working on Hadoop generation one, that is 1.x.x. Okay, so this problem has been overcome in Hadoop generation 2.x.x. Okay, so I hope this thing is clear for you people. Next, so important points to be noted: Hadoop employs a master slave architecture. The distributed storage system is called Hadoop file system. Okay, the name node is the master of HDFS that directs the slave data nodes daemons to perform the low level IO task. Name node is like bookkeeper. Okay, see over here, this name node is like the bookkeeper. It keeps track of the information or the blocks that are available on the slave nodes. Okay, it's like central of failure. Okay, if name node or this master is gone, if it is down, then there is no cluster, there's no control over the cluster. Fine, so that is the point over here. Name node is the single point of failure. Fine. Next, so I was speaking about the data getting replicated, the data getting divided. Okay. Now suppose this is the master and these are the slaves. Okay. Now suppose there is a file. Okay. By name data 1 and there is a file by name data 2, and this file wants to get stored on this cluster. First this file, okay, by through the user is having giving a request to this master. Then master, okay, in coordination with some of its components or the configuration, will divide this file into blocks, say block 1, block 2, block 3. That is data 1 is divided into block 1, block 2, block 3, and their replication. One is the replication for 1, the 3 replication for 2, 3 replication for 3. Okay, so see over here, replication 1 is available here, 1 is available here, 1 is available over here. So by default the replication factor is 3, so which is easily configurable in the software package, Hadoop package. Okay, and over here one more thing is the block size. The block size is 64 MB. Okay, this block size is 64 MB. All the block size over here is of 64 MB. So over here the data 1 is divided into 3 blocks, 1 1 1 and its replication 2 2 2 3 3 and 3. Okay, so advantage of this is if this node is down, then what all data I have lost, say 4 5 3 2, 5 is available over here, 5 is available, 3 is available over here, 3 is available over here, 4 is here, 4 is here, then 2 here, here. So you need not worry if any one of the commodity machine is down. Obviously its replica is available on other machines. Okay. Now file blocks will have some study over here. By default in Hadoop generation 1, the data is split into 64 block MB. 64 MB block, and generation 2 Hadoop 2, the data block size is 128 MB. Okay, now suppose consider a file abc.txt of size 200 MB. Considering that you are working on Hadoop 2, then the file would be divided into 128 MB of one size and remaining 72 MB. Okay, now you might be wondering why 72 MB. If you are saying that the block size is 128 MB, then why not 128 MB over here? Why only 72 MB? Okay, I'll tell you one interesting factor. Now if you consider about your normal file system that is available on your hard disk, okay, it is divided into what are called as tracks and sectors. Okay, you have certain tracks and sectors available as part of your hard disk. Okay, now if I consider this part, okay, this would be considered as one block in your normal file system. This is one block. The size is 4 KB. The size of this block is, okay, this block is 4 KB. Now suppose there is a request to store 2 KB of data, then this 2 KB of data would be stored in the part of this 4 KB, and what about remaining 2 KB? It would be lost. It would be wasted. Getting my point? So in your normal file system, if the block size is of 4 KB and you want to store 2 KB of data, then the remaining 2 KB is just lost. Getting my point? So that is not happening over here in your Hadoop file system. When I say 128 MB, and if there is a case of varying data block, then block of that size is created rather than another like overall 128 MB and the remaining is not used or wasted. It's not happening over here. So data storage is done at the optimal level. Fine. There is no additional or there is no data like block being wasted. Fine. Now, for example, another example, if you consider a file xyz.txt of size 500 MB. Okay. Now, you want to store this 500 MB on Hadoop generation 1. Okay. In Hadoop generation 2, the size I said it is 128 MB. In Hadoop generation 1, the size is 64 MB. Okay. So how many blocks? Okay, the 500 MB block would require how many? 7 blocks of 64 MB and one block of 52 MB. Okay, so overall 8 blocks you would be needing. Okay, overall 8 blocks you would be needing. Okay, taking another example over here, you have a master and one master and 4 slaves. Okay, now suppose I want to store 100 MB text data, then I think that you are working on Hadoop generation 1, then I would be dividing this 100 MB into 64 MB one block and 36 MB another block. Then after creating one block of 64 MB, I create the replica of those. So block 1 replica 1, block 1 replica 2, block 1 replica 3. So 64 MB is 3 replica, then 36 MB is 3 replica. So 36 block 2 replica 1, block 2 replica 2, block 2 replica 3. Okay. Now these blocks I have, okay, it has been scattered amongst this cluster. Okay, so block 1 replica 1, block 2 replica 1, block 2 replica 2, block 1 replica. So they are been like distributed amongst these slaves. Okay, now these data nodes, they send a periodic heartbeat signal to the name node, okay, about the block information. That name node will keep a information about those blocks. Okay, so that information is nothing but what is called as metadata. Metadata. Metadata is data about data. Metadata is nothing but data about data. Okay, so these blocks are there, no, they are nothing but your data. Okay, you are storing the information about those blocks, so it is nothing but data about data, that is information about the blocks. So what does this specify is block 1 replica 1 is stored at slave 1. See, block 1 replica 1 is stored at slave 1. Okay, block 1 replica 2, block 1's replica 2, okay, block 1's replica 2 is block 1's replica 2 is stored at slave 3. Okay, block 1's replica 3 is stored at slave 4. So this is the metadata. Okay, so this metadata is stored on the master node. Okay, if master node is down, then this metadata is gone, then this Hadoop is in an inconsistent state. Okay, so I hope you have understood the overall working of how actually internally blocks are been created and how the blocks are being stored, how the metadata is stored on the master. Okay, so we'll just stop over here, and we'll continue our discussion in the next session. Okay, I hope you all have enjoyed.